Wi-Fi node MCU, relay module, and light bulbs. Next. And for the schematic design, the 110 AC power connects to one side of the light bulbs, the other side is connected to the relays that are controlled by the node MCU. When the relays are activated, the internal switch creates the circuit that turns the light on and off as the schematic explained. Pin D, pin DO of the MCU is connected to R1, which is the relay 1, D2 to relay 2, and D2 to relay 3. The relay module receives external power from a battery pack. So the 5 volts power supply, the 1 ampere, it is optional, but we may use it in order to avoiding the lack of electric current by supplying 5 volts to the relay. The ground of the battery pack connects to both the node MCU and the relay module. The node MCU is powered by a USB cable. And for the project detail, next po sir. For the project details, you are using Node MCU. Node MCU is a low-cost open source IoT platform. It initially includes firmware which runs on the ESP8266 Wi-Fi SoC from the Expressive Systems, and hardware which was based on the ESP12 module. Next slide. And for the relay, a relay is a programmable electrical switch which can be controlled by Arduino or any microcontroller. It is used to programmatically control on and off the devices which use the high voltage and or high current. And for the light bulb, next slide. A light bulb produces light from electricity. In addition to lighting a dark space, they can be used to show an electronic device is on to direct traffic for heat and for many other purposes. Balloons are in use, so even in outer space. And for the blink up, next slide po. For the Blink app, this project uses Blink mobile app to connect to the server and control the lights. Also, it is using a single channel relay to act like a switch. For the Blink app, provide your project a name, and as Blink app works with different hardware models. Here we are using ESP8266 Node MCU, so I am proceeding with Node MCU. While selecting your board off to your for your association sort, whether or not it's Wi-Fi or LAN or USB association. After these steps, click on Create button to form your project. As the blank project opens, add widgets to it by clicking on Add button. Next slide, sir. Now, after this, click on button to add a button in this project. Now, in button settings, provide the name to your button. After, assign the pin number to the output. So I select the pin number, pin for virtual, VO, and so on. After assign this pin number to output, also gives names to your on and off labels. That's all, sir.
That was pretty good. Which is this is your first milestone, so that shouldn't have been, that complicated, right? So for the most part, you guys are done here. One thing I have to mention in terms of, one of the when I listened to your defense on Friday, that was Friday, yes, I think so. Uh, so many days already passed. You guys basically had to follow a specific format. I never gave you guys a format, but for the most part, Google Slides comes with the, at least the format that we accept here in the United States. So it looks nice when you change things, but there's no points taken off for this because there's not a guideline for that. But for future reference, especially when you go to college, you have to follow a specific format for the things that you are going to do. So especially in font size, font type, but this looks nice. So you did follow the non-linear. I think at some point you guys changed something here. I don't know why. Yesterday this was all the way here, and sorry, I don't think you're seeing what I'm seeing. So however, I mean, it's fine. I don't know if you why you guys changed the nonlinear thing, that which was a requirement, but one second. So yesterday when I saw this was a nonlinear format, that this slides right now, I actually moved this right now, but it was right here right now. So what I'm trying to say is that if you did, I'm not quite sure if you did, but actually, yeah, I think you did it. This should be here. This should be here, and this should. Yeah, I think it'll pass. I'm not gonna make a big deal about it. It's just because that's what pastor required also. But but you guys know what it is. It's not like nonlinear format is actually what you call it, a big deal. Actually, I don't like it at all because it's kind of unorganized, especially when you're presenting. If you're teaching, yeah, that's fine because you can jump from slide to slide, and that's not a big deal at all. But presenting, I think you want to have some sort of organization when you're actually, showing some product to whoever. But yeah, perfect. Now let's go with oh, actually, you know what? Can somebody there please make me a host, because I cannot record this thing. It's telling me that ask the host to for permission to record. Can you guys please take care of that before we start the next one? I don't know who is at church or if the church people is listening to us, but that'll be nice. If not, I can just record it in OBS, but I don't know how's that gonna sound. Yeah, don't worry about it. I had an OBS. Don't worry about it. Oh, wait. Never mind. So OBS doesn't have audio. All right. Nobody's at church that can request this. Let me see. Okay. Never mind. All right. I guess we're not gonna record it. Let's go with the next presentation, which is
Excuse me?
yeah.
Don't worry, it's live on YouTube.
Oh, okay. That's perfect. All right, great. So let me find this guy's presentation here. What's the name of it? I have so many presentations here. I already lost track. Is it called? Oh, right here. I should know because you guys changed the color. All right, so we're gonna start with Bravo, and I don't know who is gonna speak first, but we do it the same way. You guys tell me when you're gonna go the next slide, and I take it from there. So let me just switch the screen here and fix this. All right, guys. So it's all yours. Go ahead.
So we are Team Bravo. We will be presenting our part in the robotic rover, the DC motor, and the screen messages. We will start with the description. Next slide, sir. Ludwig, you may proceed.
Okay, so for our description, the DC motor is responsible for providing power to the rover, for which adjustable speed in constant or low speed rotation is required. They also work in braking or backward use using a pair of batteries in the process. It includes the following components: a V5 sensor shield, DC motors, and a battery. A screen messages is basically just text of words giving instruction, words like stop, go, continue, and etc. Unlike the screen pattern, which are symbol and icons. Next slide, po, sir. Then,
Project details. V5 sensor shield. It allows plug and play connection to various modules like sensors, servos, relay buttons, potentiometers, and more suitable for Arduino Uno and megaboards. Next slide po. Batteries. It is a device consisting of one or more electrochemical cells with external connections for powering electrical devices such as flashlights, mobile phones, and electric cars. Next slide po. A DC motor. is an electric motor. An electric motor is an electrical machine that converts electrical energy into mechanical energy. Matrix panel. It is a dot matrix of large display low resolution value and is useful for both industrial or commercial displays as well as for hobbyist human interface machines. Next slide po. A dual point line. It is an electrical wire or a group of them in a cable with a connector or pin at each end or sometimes without them, which is normally used to interconnect the components of a breadboard or other prototype. Next slide, please.
In our schematics, these are the example of screen messages, the symbols like the word stop, and yeah. We use a LED matrix and a DuPont line, which basically connects it to the LED matrix. Yeah. Next slide. Um, and this is our code description.
Okay. All right. So for this part, let me see. Where are we here? All right. So for the code description, I think this is fine. Yeah, because there's a lot of code. Let me just double check this thing. Where are we here? Whoa.
The code link, sir, I already changed the mistake I made.
Oh yeah, wait. I am completely lost here. Yeah. So there's a code link here and I looking for the code. Seriously. Okay, so this is basically this is just a bunch of a lot, code that is just unfortunately because of the matrix, since it's pretty old, not old school, but it's kind of native, like not the one I have here that you can actually enter full paragraphs and it will display just by clicking enter. This one you kind of actually have to code it, hard code it one by one. So we kind of run into a little issue here that it was I'm going to explain why a lot of these things I had to change myself. Like, for instance, this one here, that one, it's already one here. So something we learned in the previous, classes does that you cannot name one variable with this. I mean, more than one variable with the same name. So I kind of have to just do something like this. Oh, wait, it doesn't allow me to change because this is just a link. So I will have to add it to my thing. However, I just kind of change it here, I just add a little extra, what you may call it, like if I probably go here and explain, let me just add a piece of code here. So if I already have a variable named one, obviously, let's just say int one, and there's no value. Let's just do it like that. I cannot reuse that name because, there, it has its own unique identifier, right? So where is this thing? So let's see. So here, what I did in the code yesterday, because we were troubleshooting, I just rename it per se like this, and 1A. So that we have two different variables named one. That's it. That's the only thing I wanted to comment about it. And here seems like you did have some sort of repetition. But that's it. That's minor. So yeah, that works. No big deal. The only thing kind of missing here is a little bit of a explanation of the functions. But since we are actually presenting this project again, I mean, as a whole, like all 4 projects, you guys can add that later because we will have all a PDF file with all the projects and all the presentations. So yeah, that's still a pass. Actually, Hannah, can you please open the wait a second. I have to send you the link. Um wait. Can you please open the grading thing for the midterm? What is it? All right. If you can find it, please. You know that spreadsheet that I have all the grades. There's one for the midterm. I think I sent it to you before. You please check in your lectures here, attendance. If not, don't worry about it. Later, I'll tell you who. I'll tell you the grades later if you cannot find it. But anyway, so let's move on to the favorite one. Huh? Who's next? That's the girls. Okay, so I am going to mute myself and remove my face out of that thing so you guys can take care of it. All right, so it's all yours.
So good morning, everyone. We're Team Charlie with my team partner, Jasmine Santiago, and we will now discuss the screen pattern of the robot, of the rover. So next slide, sir. Next slide po. So for the description, screen pattern is used to know the status of the robot. Screen pattern is important because it provides us the framework for clear information about the robot. So the dot matrix is a two-dimensional patterned array used to represent characters, symbols, and images. Every type of modern technology uses dot matrices for display of information, including mobile phones, televisions, and printers. So the project details of screen pattern are V5 sensor shield, LED matrix, and DuPont cable connector. Next slide po. So project details. V5 sensor shield. The sensor shield's purpose is to make it easy to connect cables and devices to the correct Arduino pins. It is not an active device. It simply connects the Arduino pins to many connectors that are ready to use to connect to various devices like servos and sensors with simple cables. Next slide po. LED matrix. LED matrix is a dot matrix of large display, low resolution value, and is useful for both industrial or commercial displays, as well as for hobbyist human interface machines.
DuPont cable connector. DuPont is also called jumper wire cables. They are low cost and used to connect hardware such as sensor, Arduino boards, and breadboards together. Next slide, please. So B5 sensor shield and LED matrix is connected to jumper wires and next slide please po. And LED panel is ground voltage common collector and serial data and serial clock. And B5 sensor shield is negative ground, positive positive voltage common collector, and serial data and serial clock. Next slide po.
Okay, I see that. Okay, I have a question. I think who took care of the servo and the ultrasonic sensor though? I don't see it in your. I thought I assigned that to you guys, but it's not here. Let me double check, okay? Because I might have made a mistake myself, but as far as I remember, I assigned you guys with the ultrasonic sensor and the servo. But let's make sure, because since you guys lose the member, I think that's only fair that we, only assign you one device. But the idea was that William was gonna help with the other part. So let me just try to open this thing. Go to Arduino. What is this? Okay, so let me just double check here what happened. Charlie team. Clock. Trick, you see in your code, you do have the ultrasonic sensor though. So you guys missing that part. I don't know why it keeps going like that, but okay, but don't worry about it. I mean, we still have to implement it because you guys did lose a member. But you see all these functions here, they all for the ultrasonic sensor, and this was just for Bravo function. They don't have to worry about that. But yeah, I don't have my file where we send too many things in the chat rooms that they all get lost with but yeah, I did not notice this last time when I talked to you guys, that you guys are missing the ultrasonic sensor. But I'm giving you a break because I know you lose one member. So I can help you integrate it later, because we do have to have all the documentation for the end of the semester. And yeah, so pretty much all teams are missing a lot of description of the code. And obviously I don't expect you to explain all this, because a lot of these things are pretty, are not supposed to be covered in this course. But for instance, I added explanations here, like Robinson's right, all that, they're calling functions here. And yeah, so pretty much all teams are missing that part. So far so good. I haven't checked the next ones, but you guys do have to kind of create a little bit more of elaborate more in your code part. And for the ultrasonic sensor, don't worry, I will add it myself here, which is not a lot, but it should be in this section. But like I said, since you guys lost the member, and Jasmine was pretty overwhelmed with the capstone too, so I'm not going to take points off for that. But we do need, for so far, both teams need a little bit more explanation of the functions, just exactly like you guys did it in the first place. On the first presentation. So yeah, good job. But still incomplete. But yeah, we still have, until our last thing. And for the final presentation, we're not gonna go through the whole thing again, but we do need to have documentation of all the projects. And that's something that I've been asking you guys to do since the first time. Just like the thesis that you guys wrote, the senior students, that it's called documentation of your project. This is just a presentation, right? However, we can use it as a documentation since this is not so advanced. And I do see a lot of, another thing here to mention is that when you are presenting a PowerPoint, a lot of this is too much text. I'm not taking points of it. I'm just giving you reference for your future classes. You're supposed to be, this is supposed to be in your notes, and basically you kind of explaining what these things do, mostly with illustration or schematics, and but too wordy. This is just constructive feedback. Though you don't, it's not a requirement. It's not going to affect the total grade. However, when you're presenting a PowerPoint, you're not supposed to, you know, do too much text, because basically you are just giving your audience things to read, and nobody wants to read a long presentation, trust me. Why that matters is because when you are actually presenting a project to, you know, a potential client per se, they don't want to read all that. They can just look it up on Google and see what it is. So, but you know, that's just constructive criticisms, and I'm gonna do it for every presentation, so don't feel bad. So yeah, thank you so much. Great job. We will still have to, Bravo and Charlie still have to add a little bit more elaboration here in terms of your code, because I don't see any definitions on the code. So Tapos, let's go to the next one. Thank you. And this is Steven and Hillary. All right, you guys ready to go?
Good morning, everyone. I'm Stephen Jan.
Good morning.
And I'm Hillary Heath.
And we are Team Delta. Today we will introduce our presentation about light sensors. Next slide, sir, please.
This is our project description. Light sensors measure illuminance or light, which can be used to measure more than the brightness of a light source. The most common light sensor type that's used in a light sensor circuit are photoresistors, also known as a light-dependent resistor or LDR. Photoresistors are used to simply detect whether a light is on or off and compare relative light levels throughout the day.
Next slide, sir. Our project details are light sensor, passive device that converts light, whether visible or in the infrared part of the spectrum, into an electrical signal output.
V5 Sensor Shield, an Arduino Uno compatible sensor shield that allows you to plug sensor modules into the Arduino through the shield just like a Lego blocks. Jump wire, an electrical wire or group of them in a cable, with a connector or pin at each end, which is normally used to interconnect the components of a breadboard. Next slide.
Next slide. And here's our schematic. We can identify the two light sensors, right and left light sensors. A sensor is a device that is used to detect changes in quantities or event of appropriately produce the output. Those particular wires are called jump wire. Jump wire are simply wires that have connector pins at the end, allowing them to use to connect 2 points without soldering. Jump wires are typically used with breadboard and other prototyping tools in order to make a change a circuit as needed.
Next slide, please. The GND stands for ground or grounding, originally began as a safety measure to prevent accidental electrocution. The VCC stands for voltage common collector. VCC or voltage common collector is the higher voltage with respect to the GND or ground. VCC is a power input of a device. It may be positive or negative concerning to the GND. Next slide po.
That's your code, right?
Yes, sir. And
Okay,
here's our code description. We can see codes to show how the light sensor or photoresistor will detect the illuminance of light. We can also notice that every line has its own function to go forward, to turn left and right, and to stop.
That's our presentation for today. Thank you for listening. Have a great day.
Okay, well, that's exactly what I was looking for on the past two previous presentation. This is a much rather explanatory code. Obviously, this presentation is a little bit rather esoteric. That means that it's intended for people who, this is not intended for a normal user to understand. Like if you show this to your mom, she's probably gonna be like, what? Pero it's pretty technical, and this is exactly what I want to see from the other two teams. This code actually is self-explanatory, and I can see the functions, I can see the variables. Obviously, you don't have to explain line by line, and for the most part, I gave you guys the code already with a lot of explanation. So pretty much what you guys had to do here was, create some sort of a file or a new sketch with the most important functions, and just leave the explanations there. So this is perfect. That's actually, you guys are done with this one. Beautiful. So what else is here? You guys also changed the color, the format, but one thing is, this is not a computer class. This is a programming class, and we're not going to be teaching how to use this sort of resources like Word or Excel or anything like that. So, but I'm just giving you constructive feedback for your future classes, because once you get to college, all this matters. It doesn't matter if you are computer science major or if you're a sociology major. These are things that you are going to be required to learn as you go along. So as public speaking, which is speech, the ability to use Word, PowerPoint, Excel, and all those things in combination, also, at least in America, it's a requirement. And I saw the capstone requirements, and they're pretty high in their standards there. So yeah, you can expect to have a lot of feedback in the future about this. But this is exactly what I was expecting. So thank you so much. That was great. We have one more team, and we have an echo team, right? That's Iambic and Ephraim. They took care of the Bluetooth module, and that's the last part. So I'm gonna mute myself, and then you guys just let me know when you need me to change the next slide though. Okay.
So welcome guys, we're Team Echo. I'm with Big Diamante, and we're doing the Bluetooth part in the robotic rover. So can you we did the Bluetooth module with, and sir, pabalik po sir.
Ephraim told you to bring it
Sir,
back.
can you back a little bit? We did the Bluetooth module that control the connection of the rover to the controller. And let's go Iambic for the project detail.
Next slide, sir. Project details. Bluetooth module is an easy-to-use Bluetooth SPP. Serial port protocol module. Designed for the transparent wireless serial connection setup. Next slide, sir. For our next project details, HC05 is a Bluetooth module which is designed for wireless communication. This module can be used in a master or slave configuration. Next slide, sir. Electronic design and schematic. Data mode, exchange of data between devices. Command mode, it uses AT command which are used to change setting of HC05 to send these commands to module serial. USART port is used. VCC, connect 5V or 3.3V to this pin. GND, ground pin of module. TXD, transmit serial data wirelessly, receive data by Bluetooth module transmitted out serially on TXD pin. RXD, receive data serially. Receive data will be transmitted wirelessly by Bluetooth module. State it tells whether module is connected or not. Next slide, sir. Electronic design and schematic. Bluetooth module RXD connect to TX, TXD connect to RX, GND connect to negative GND, VCC positive VCC. No need to attach the state and DR pins. Next slide, sir. Efrain.
Sir, the next slide is the code description. So,
Okay, so you guys are gonna give any description or not?
what, sir?
Are you guys talking about the code or not at all?
We're gonna talk,
Just,
sir.
all right, go ahead. Sigue, sigue, sigue. Let me mute my.
So wait, sir. The child which named Bluetooth variable save the value of Bluetooth reception and in the void of the Bluetooth values will in the case F to forward command and the matrix display front so show forward the sign and the matrix display back show back pattern in the case LF turning instruction which display matrix show left turning sign and the case R which right turning instruction which in the matrix show right turning sign. So that's it, sir.
Okay, very good. You see, so we had two teams that actually took the time to describe what they were doing. Wait, hold on. Hey, Vector, go to sleep. Go to sleep. We might get out and start pushing things. It's still dark. Okay, so one thing to mention here, this is nice. When you are presenting, you should not use the word we. This should be a little bit more of a, this project is, you know, so and so that this part of the project covers or whatever you want to say, but don't try to use we or I or, you know, kind of things like that. That's pretty, this whole slide is just kind of like necessary, but I appreciate what you guys are explaining here. Like I said, this is just constructive feedback. This is nothing that is going to affect you at all. This is just for, again, your future classes. All right. What's next here? This could have been combined here. This is, if you guys didn't know how to do this, I don't know why it's going all cuckoo like that, but I guess something happened to the text box. Here is fine. Yeah, I like it. That's fine. That's nothing. I mean, it's just giving a description of the components. Here, instead of using numbers, you should not use this type of format because, you know, you have 1 and 2 and then you have 2. So instead of numbers, you can just use like bullet points. Rather easy to do that here. Let me see if I can do it. You see, I don't know what happened, but yeah, you get my point. Don't use numbers when you're listing things, just use bullet points. And ideally in a PowerPoint presentation, this will come, you know, if you guys have ever used PowerPoint, we're just kind of like going through the slides because it's kind of hard to, you know, control this thing through Zoom. However, if you actually go to present, this thing should come out one by one. When you press the space bar, it will come out. You talk about it and then the next one and next one and next one. But other than that, this is fine. Since we didn't really have, this is a rather unique schematic coming from the company, we couldn't use our own. So like, you know, like in other projects that we actually had to use Tinkercad or whatever developing software we using to create designs, this is what they gave us. This is what we have to use, unfortunately, but you know, it gets the point across. And this is perfect. You didn't have to add this card because this is, I mean, this slide, because there's really nothing here for us. Actually, the only reason I added this empty functions that belong to Bravo is because they're actually called in here. So you see, right? We never actually discussed how to create external files or anything like that, that probably for a more advanced class next semester, but I didn't really see the need to it. And then we kind of keep dragging this project already way too much. So, um, I mean, for the most part, everything is nice. I like everybody's presentation except for the Bravo and Charlie. Charlie missing that part, but don't worry about it. I will add those here and just try to elaborate something here. Um, for instance, let me see if I actually have something in here. For instance, you only show me the characters. This really doesn't show me any information at all. I just see a bunch of variables and a bunch of hex addresses that if I was just somebody from the electrical engineering department coming to see, and I'll be like, wait, what is this? So if you show me here, I actually added pretty much all the comments in each of each line of code. You see this one covers the entire movement patterns. So, and this one actually covers the pins. This is motors pins. Obviously I had to add that in here because that's part of wait, this is Bravo. I'm sorry, I'm reading the wrong code, but however, you get the point. Let me just go there real quick. This is Charlie. So in theory, all you had to show me here is a little bit of a explanation what the part of the project, what the component of the project that you're covering is doing. This is the most complicated one because this one covers the matrix and also covers the ultrasonic sensor and a servo. So this is your function to control the servo. We discussed for loops. You don't have to explain line by line by line, but if you give me a brief explanation, that would be nice. Other than that, I think we're controls the ultrasonic sensor, you see. And this you don't have to touch because like I said, you guys had to work in collaboration with each other because since this is part of Bravo's team code, you guys basically, let me see here. I'm sorry, I gotta go back. So Bravo pretty much did the same thing you guys did. So they had the matrix and you guys had the matrix too. So let's work on that a little bit. Add the ultrasonic sensor here. And like I said, since you guys lose the member, that's understandable. All I want from you guys is to add the code description. I will add the extra slides with the ultrasonic sensor. And what else we have? The servo. Servo is easy, and the ultrasonic sensor is just, the formula to measure distance is right here. So you don't really have to worry about that because it's already here. So for statement, blah, 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 blah. I don't even know what I'm looking at. Oh yeah, it's right here. So this is your calculation of distance. Just make a brief explanation for that. Other than that, everything is fine. Who else? Now let's go to the MVPs of the class. What happened to Alpha here? They give me, all right. So my point with Alpha team is that up until this point, we don't really know what you guys are gonna do. And that's what I have been repeating over and over. I know you guys showed me this yesterday and I say that looks fine. My point is that we already seen your prototype twice or three times. It was incomplete. Now this works. Now from today up into the final presentation, I need you guys to have a concrete idea of what you are going to do. This is just a prototype, we know that. But up until this point, I don't know how this is going to be implemented into the actual, into practice, right? This is, yeah, I know this is what you guys are doing, and it looks nice. However, I do need to know what you guys are going to do in this project. Um, is it going to be fans? Is it going to be lights? Or is it
Uh,
going to be
can
lights?
I?
You guys can do half lights, half fans. You know, it's not whatever you guys want to do. Another thing we can do, and I was
Hello?
thinking, if you guys don't want to break your head too much, is what if instead of, we can do a prototyping with all 8 relays and just add let me just go here.
Hello.
Yeah, go ahead, you can
Okay.
speak
Okay.
now. Go
So
ahead.
our point is why we made a prototype with only 3 light bulbs is because um, we don't know the exact amount of lights in the church, but with this prototype, we can actually implement our 8 relays. Uh,
Okay.
that was one of our reasoning on why we just use 3 relays, because essentially it's the same if you made it into 8 relays. You just need to add more wiring, but
Yeah, that's
it's
true.
essentially the
Yeah, yeah.
same.
No, I
And
no, that part I completely understand. I just still unsure exactly what you guys are trying to, how you guys are going to implement your project. The prototype
so
is,
uh, we are going to implement it by of course, for starting with the wiring of the church. Every lights, it has a series of lights, 3 on the front, or 2 on the front, 2 in the middle, and 2 in the back. We are not messing with the lights up above, but rather we're messing with the lights.
all right. So you can actually include that in your limitations. So my only, this is you guys project. I'm just giving you some ideas. Another thing that we could potentially do is the following, and I'm trying to find an image to, so I can kind of paste it there. What instead of 3 light bulbs here, which is obviously, this is just a prototype. No, we're not using this as the actual thing. We can put this old 8 what should we call it, 8 electrical outlets, and that way we can just plug in like a bunch of fans there, a bunch of lights, and then we just kind of have the because realistically speaking, for you to mess up with the lights, you're gonna have to have somebody there, which I'm not saying you guys can do it, but if you guys are gonna be messing with the actual electrical system of the church, you will gonna need somebody who can actually what you call it, help you guys with the wiring. This is not something you can do with, you know the direct tape and all that stuff. You just kind of go like that. No, it
Yes.
has to be down, because there is a potential of a fire hazard, or somebody getting not electrocuted. You're not gonna electrocute yourself with 110 volts, but you know, when I was in college, we used to just play with it just for fun and see who can handle more. But uh, we want to take of all the safety precautions here, because obviously these are the church lights and they need them. And we don't want to one day to tell Alexa to activate the light and all of a sudden you start seeing a firework there. So you still
Yep.
have time. I mean, we still have what, 3 weeks? Wait, 2 weeks
I mean, for
to.
the we actually know someone is from the church too, who can assist us with the
Right.
wirings or electrical stuff. He can
Now,
assist
I
us.
when I watch the services, I do see a lot of fans there. Do they serve any purpose? I mean, of course they serve a
Yes,
purpose.
of course they do.
Are they connected to? Obviously, it's hot, right? I have a fan here. It's so hot right now. What I mean is that, are they wired into the wall, or they just have plugs?
They are wired. Some are actually all of them are wired to an extension.
I see. All right. You guys can just do that, but Pastor said he wanted to see lights. We can do a couple of lights. The only thing, we have a module that it's in an array, right? So we have all the relays are attached together. Unfortunately, that's the way that we have it. However, I think we can come up with something. But my major concern is that the more we keep prototyping, the less time, the more time we're wasting, and the less time we have to actually do an actual implementable project that it's going to be functional, because it has to serve a real purpose, right? That was the whole point of that. Other than that, this is fine. I already get what